Hello everyone, thank you for joining us in this lesson. Today we are going to talk about closures. This is a really exciting topic, so please do follow along, like and subscribe. The official definition of a closure is essentially an anonymous function that can capture its environment. That means, unlike functions, you can capture a variable that sits outside the body of the function without having to reference it as a parameter. Now, the way to declare what we call a closure expression is to declare it with a let keyword, and then you use the vertical bars or the vertical pipes, and then you open the expression with curly braces, just like you see here. If that closure takes in a parameter or two, you would put the parameter between the vertical bars. The other rule is, if your closure has only one expression or statement, then you don't need to put the curly braces, as you can see here. At line 2, I'm declaring a very simple closure that takes a number as a parameter and just increments it by 1. And as I mentioned before, we don't really need the curly braces because we only have one statement. So let's remove them. And then at line 3, I am printing this closure return value. Now the closure at line 2 is acting just like a normal function. It's not really capturing a variable from its environment. So in these cases, usually you don't really need to declare a closure. There's no point really, because it's not doing anything interesting. Now, if you move on to the second example here at line 5, I am actually capturing a variable from my environment. So this variable, the one that is declared at line 5 called my value, I am capturing it inside the closure at line 6, and this is closure 2. And then as part of the closure expression, I'm just adding these two variables together. At line 7, all I'm doing, I'm printing the return value of closure 2 to the screen. The interesting thing here is I am not really specifying the type of the parameter or the argument for the closure itself. So at line 6, for example, I didn't specify that num is an I32. It is inferred by the closure itself. Let's try and illustrate this with a better example. Now at line 9, I am declaring a closure that takes an argument and then just prints it to the terminal. It's not doing anything clever. And then at line 10, I'm trying to call this closure with a string as an argument. And at line 11, I'm trying to call the same closure with an integer. Watch what happens when I try to compile this program. Okay, so as you can see, it is complaining, saying I was expecting this type, but at line 11 you're using an I32 instead. You should be using a string literal as an argument for this closure. Now if I try to comment out the statement at line 10 and leave the statement at line 11, you will see that the compiler is more than happy to let me use an I32 as an argument for this closure. So this is what we mean that the closure infers the type that you're using as an argument. This is a really powerful feature of closures. You can actually write pretty generic functions using closures themselves. So let's illustrate this with an example. At line 13, I'm declaring a closure called closure number 4 with two parameters, x and y. And then at number 14, I'm calling the closure with two I32s. What this will do, it will add these two variables together. So the result for line 14 will be 2. And at line 15, what I'm doing, I'm also trying to append two strings using the same closure. Of course, if I were to execute these two statements right now, it will fail because the closure has inferred that any subsequent calls should be in I32. So if I comment one of them out, you will notice that the other one would work. But the interesting thing here is that we've made our closure generic enough that it can take either two I32s or F32s or even strings. It can even append two strings together, as you can see from the result here. Now this is where closures get a little bit more complicated, but again even more powerful. As mentioned earlier, the difference between functions and closures is that closures, they do capture their environment. if there was a variable that was declared outside the body of the closure itself, it can be brought into the body itself and then immutably borrowed, and it can be mutated, and all sorts of things happen to that variable. Now with function, you have to explicitly define what happens to any variable that you add as a parameter to that function. You could be defining that input parameter as an immutable reference, or it could be a mutable reference. Now, when writing closures like we did earlier, Rust most of the time captures these variables implicitly on the fly without any type annotation, and most of the time you don't have to worry about any of this. However, if you are defining functions that take closures as parameters, for example, you need to start to worry about these things. But anyway, before we get into functions that take closures as parameters, let's define the different capture types here that closures takes. Just like function, there are three different ways a closure can capture a variable from its environment. It can either take ownership of that variable, it can borrow it mutably, or borrowing it immutably. The way it does that is by using traits. Now there are three traits that a closure uses. There is the FnOnce, which essentially consumes the variables that was captured and it's no longer available after you call that closure, so you can only use it once. And there is the FnMut, which is essentially mutably changes that variables, right? So once the closure captures that variable, it can mutate it. And there is the Fn trait, which essentially just immutably borrows value from the environment. And most of the time, Rust just infers which trait to use based on how the closure is using those variables inside the body of the closure itself. And the only time you explicitly define these traits is when you create a function that takes a closure as a parameter. For example, if I look at line 2 here, I am declaring a simple variable that takes a string. At line 3, I'm not doing anything to that variable other than just printing the value of that variable to the terminal. So that essentially captures the variable with the Fn trait because it's immutably borrowing that variable to print it to the screen. It's not doing anything to it. Now the second example at line 6 here, I'm declaring a closure that actually mutates my str1 variable that I have declared at line 2. So this particular closure will use the FnMut trait because I am mutating that variable. It infers from the way I'm using that variable using the push str function on that variable, it infers that this is the trait that I need to use for this closure. And of course, the last example here is FnOnce. So at line 10, you can see that I'm actually dropping str1 entirely, and once you call that closure, any call to that closure again, any subsequent ones will just fail. It won't work because it's using the FnOnce trait simply because of the fact that you just drop at line 10 there in the function body. Okay, let's move on to something different now. I mentioned earlier about the function that takes trait as an argument. This is where you need to explicitly define which traits you'd like to use for your closure. As an example, I'm creating a function here at line 1 called add5. All it does is essentially just adds 5 to any number that you give it. At line 2, I'm making sure that my closure is of trait Fn. That means I can only immutably borrow whatever value that's given to that closure, which in this instance is an i32. And then I go into my main function here, and at line 6 I'm declaring a variable called num1, and then at line 7 I'm using the closure as supposed to be used, i.e. just adding 5 and then just printing it to the terminal. So this works. I'm not doing anything clever here, I'm just immutably borrowing the variable itself. However, watch what happens when I try to mutate that variable but not change the way I'm declaring my closure at line 2. So let's change our variable here at line 6 to make it mutable. And then let's try and increment num1 at line 7 and then see what happens. Now, trying to increment num1 variable in this way will trigger the compiler to detect that the trait that it needs to be using is the FnMut. However, I am explicitly defining it just as Fn at line 2. And as you can see from the error here, it's actually giving you a hint saying change this to accept FnMut instead of Fn. So if we do that real quick now, so at line 2 I change it to FnMut instead, and it will work just flawlessly. So this is a really good example to illustrate how both Rust automatically infers what type of traits to use in a closure, and what happens if you explicitly define a function that takes a closure with a certain trait, but the inference on how you're using it is slightly different from the way you defined it. Okay, let's bring everything that we've learned together here around closures and make a good use out of it. Now at line 1, I'm just declaring a simple struct that takes a set of classic cars with two fields, one called the make, and then the second field is a vector of tuples that contains the model of the car and the year it was manufactured. Essentially, from each manufacturer, we want to put all the models that we like or our favorite models for that particular manufacturer. So in the case of Ford, for example, you have your Ford Mustang and your Ford GTs in there. At line 6, I'm starting to add the implementation of the classic cars struct by defining a method at line 7 called smartGet, and this is where we'll do something interesting with closures. Now at line 7 I am declaring a function called smartGet, and this is where the fun begins really. This function does take a closure as a parameter, and I'm denoting it here as a lowercase f, and it has a type of capital F. Now capital F is just generic, and we're defining it at line 8 and line 9 with the where statement. So if you look at line 9 there, F is of the Fn trait in closures, and it takes a parameter of a reference to a vector with a tuple. As I mentioned earlier, is that same tuple with a string of the model name and an I32 that denotes the manufacturing year for the car. Now at line 11, I'm just calling the closure itself with self. Now self refers to whatever instance you've created when you declared the variable that takes classic cars, and then I'm passing it the models. Now the models just refers to that vector at line 3. Then at line 15 I am declaring my car collection vector. At line 20 I'm creating my classic cars struct, the vector that I declared at line 15. At line 22 is where the fun really begins. Now, if you're familiar with functional programming, you'll be extremely comfortable with this. All I'm doing here is I'm calling the smartGet function, and I am passing it a very simple closure that will iterate through the vector that I have here called models, and I'm filtering any car that was manufactured after 1960. Just a side note here, we are getting an iterator back from the into_iter function that gives us back an iterator that we can work with. And you'll notice that when you're using map and filter and reduce and other things, you'll be using either variations depending on your use case, either into_iter or iter by itself. You will notice here once I called collect, because I have defined the type of the returning vector in line 23 as an underscore, collect will automatically infer that this would be a vector of tuples that it needs to return. So you don't really have to specify it. Okay, let's do something even more interesting, continuing with the theme of functional programming here. Let's say, for example, if we had a requirement to prefix the model name by the manufacturing year. So essentially you can say this is 1969 Thunderbird or 1967 Mustang. You can do this very quickly using functional programming and using the map function here. So all we're doing, we're iterating through our vector using a closure and appending the manufacturing year to the model name. And once you call collect, the variable declared here at line 25 will print out the correct format that you would expect. So it will be 1969 Mustang Grande and 1966 Cobra and 1960 Thunderbird, for example. This becomes really powerful if you're creating libraries, for example, and you're distributing them to developers. As you can see, by giving them the option to create closures by themselves, you're giving them a lot of power and a lot of flexibility. Okay, thank you so much. I hope you enjoyed the lesson. Please do subscribe and like the video, and I will see you next time.